So here we are with the reaction to these stress events. This is called the general adaptation syndrome. You'll see later it's written as gas at some point. I think we're off to a good start. So the general adaptation syndrome, how our bodies respond to these stress events. We'll define the term general here in a moment, but adaptation is the important part. We've all been experiencing that recently. We've adapted to this new online learning environment. Some of us better than others. So manifestations. Can't see this, hear it, taste it, smell it, or feel it. We discussed via WebEx this morning how Cell Yi had those objective responses in the rats, whereas Cannon more or less just described stress 22 years prior. So how do we know this exists? We see hypertrophy in the adrenal glands. That's the large or the growing adrenal glands. Lymphatic organs are smaller, and the ulcers in the belly are going to be present. So this term general, large portions of the body affected in small ways. If you have a broken bone, it's right there in one spot. If you have a laceration, right there in one spot. The pain is local. This general, we can feel stress across our entire body. Dylan mentioned the issue this morning via WebEx of loss of appetite. We can feel it there. You guys, in some cases, mentioned breakouts. Our entire body is feeling that. So in a way, widespread but not acute examples of this stress occur. Adaptation portion of this means the body tries to adapt. So in acute stressors, we see that we talked about adrenaline release. That's that fear stressor. But long-term stress, something that doesn't have any closure, like this virus, not knowing anything what's going on, it makes it tough. So we'll see these stages, the alarm reaction. Oh man, what am I going to do about this? Then there's the resistance or adaptation that comes when we have a plan to put into place. And then finally, depending on the strength of the person, the extremity of the stimulus, we just get tired. We get tired of it, we don't like it, and that could happen within minutes, hours, weeks, months, or even years of dealing with these stressors, depending again on how extreme it is. So the tough folks that can handle the perception of this particular stressor are the ones that will resist the exhaustion for the longest period of time. So in discussion, we have to mention that everyone is going to see these two stages pretty much at any point in their life. Okay, we have small stressors every day, but we learn resistance, right? Exhaustion comes when it's extremely severe, as I've mentioned, or the duration of the stressor is very long. Some of the newer research, and this book was published in 2017, 2018, so it's not much of a change here. Current physiologists have modified some of the old school thoughts. So we've redefined stress as the stimulus that either directly or indirectly might stimulate neurons of the hypothalamus to releasing corticotropin releasing hormone. Right? Cortisol is the stress hormone. You go to bed angry and you wake up not feeling great because you were angry or if you're physically, emotionally stressed. Cortisol is one of those hormones. So we're trying to fight that. Um, we talk about working out all the time. As you work out, you want to recover and you don't want to be in a stressful condition because under the emotional stress release of cortisol, our bodies won't grow physically as well in the presence of cortisol. So then the newer research has come up with stress syndrome, these above conditions here, right? And we talked about today the fight or flight response, heart rate, strength, less fear, increase in blood pressure, and that's really important for fighting this off because we need that. And this is the pathway. So here's our stress event, which then goes into the brain and then hits the hypothalamus, which is responsible for our basic day-to-day homeostasis. Corticotropin, it's going to come here. Sympathetic nervous system in the brain, pituitary chain. And what does this? All of this results in the effects of cortisol. Increased catabolism of tissue proteins. That's what I'm talking about. Catabolic process, if you remember back from August, this is about digestion and consumption of those calories. And we're going to get into our muscle to do this in the presence of cortisol. Decreased lymphocytes. This is measurable. In the presence of cortisol, we have less immune response. And then more susceptibility to allergies. But then increased blood volume under these events, increased sodium in water reabsorption. So we're trying to fight against this, but we can see these manifestations. These are the objective responses that we're able to come up with in the last decade. And prior, of course, but we're talking about Canon in 1936. So we've come a long way. So some people have a healthy or even beneficial response to stress. We mentioned this in athletics, these extreme stimuli or people who are chasing a rush, adrenaline junkies, positive responses. We feel good after we go through this with success, okay? Some other folks have trouble coping and the conditions become worse. So there's some really, really aggressive therapies where we're placed directly into the environments that make us feel stressed out. So we talked about roaches earlier. Imagine just being in a room with, at first, one roach. You can't go anywhere, you can't kill it, you got to be there with it. And then you get used to that, and then we bring in 5, and then 15, and then 40, and then all of a sudden you're in this room with all, and you're either going to get over it or it's going to become worse, right? Sounds horrifying. So the body usually will respond to the smaller stimuluses, but occasionally we see some failures. So the indicators that we use today, heart rate and ejection fraction, that's that force, remember from cardio, how much blood is ejected with each heartbeat. Increased hormone production, that's cortisol. It's also adrenaline, testosterone. Sweaty palms, dilated pupils, scenarios that indicate to us physically and outwardly that our body is going through something. And this is one of those neat graphs. We did this in cardio. It's just a different form now, okay? So we can see here in the red line and the blue line, we have the control group, which is just normal conditions, and then the group that's placed under the stress condition. Or the way to read that better is just get a baseline of an individual without stress events and then expose them to the stress events and compare the two. So you can see the red shaded area is the stress event. So the changes per minute in activity, in terms of the body activity, we see this correlation, right? Beats per minute during the stress event. And this is weird. I noticed this years ago. Beats per minute. That's not accurate. So the numbers there, that's not a real thing. Okay, but we do see, just look at the graph. We can place this anywhere. The low end of this might be 70 and the high end of this might be 200, but not 320 to 480. That's crazy. Now we can see a difference from 320 to 480 being 160 beats per minute change. That's still aggressive, right? Blood pressure changes in that period of time. Body temperature increases afterwards. So it begins to ramp up and then follows this wave on the way down. And then those corticosteroids, right? Just all through the stress events. So these are notable when a person's placed under those conditions of stress. 1, 2, 3. This is, we started on 8. We're trying to make it on down to 20. So somewhere in the middle of that would be 14. So let's see what we have here. I like stopping it here. That's good. We'll call time on here. Have you guys watch this. We'll break it off into one more section to finish it. And then we'll probably meet up again and discuss, the test and stuff. But as I mentioned, that WebEx is our last test, and then we're going to move into the exam preparation after this. All right? Later.